Now we're going to go over a few more examples where we're looking for the intervals of increase and decrease of a function, and we're also looking for the local extrema of the function. We're going to go over these questions for the following three functions, starting with the function f of x defined by x cubed minus 12x plus 1. Because we are looking for the intervals of increase and decrease, and we have seen that this depends on the sign of f prime, we differentiate the function and obtain 3x squared minus 12. Since we are interested in the sign of f prime, we're going to factor it. It factors as 3 multiplied by x minus 2, x plus 2. The sign of f prime only depends on the sign of the factors, and in fact the first factor, the constant 3, is always positive, so it doesn't influence the sign of f prime. So if we try to put the sign of f prime in a sign table like we did before, so at the top we have the values of x, we need to know the sign of x minus 2 and the sign of x plus 2, and as I said, the sign of 3 doesn't matter, it doesn't influence the sign of f prime. So the sign of f prime is the same as the sign of the product x minus 2, x plus 2. The places where we may have a change of sign are negative 2 and 2. Now let's look at the sign of each factor individually. X minus 2 is positive when x is larger than 2, that means on the right of 2, so we put a plus on the right of 2. X minus 2 is 0 at 2, and negative if x is less than 2. X plus 2 is positive when x is greater than negative 2, that is on the right of negative 2, so we put positive signs on the right of negative 2. It is 0 at negative 2, and negative when x is less than negative 2. F prime is the product of these factors, so on the interval negative infinity, negative 2, both factors are negative, so the product is positive. On the interval negative 2, 2, we have one negative factor, one positive factor, so the product is negative. And on 2 infinity, we have a product of two positive factors, so we get something positive. The interpretation in terms of increase or decrease of f is that the function is increasing on the interval negative infinity, negative 2, and on the interval 2 infinity, and decreasing on the interval negative 2, 2. Moreover, using the first derivative test, we see that we have a local maximum at negative 2 and a local minimum at 2. More specifically, the local maximum at negative 2 is the value of the function at negative 2, which turns out to be 17. If you plug negative 2 in the original function, you get negative 2 cubed, that's negative 8, plus 24 plus 1, so positive 17. Similarly, we have a local minimum at 2, and to obtain the minimum value, we plug 2 in the original function. In this case, we obtain negative 15. The second function is x to the fourth minus 6x squared. Again, we're looking for the intervals of increase and decrease, and that depends on the sign of f prime. So we differentiate the function, and we obtain 4x cubed minus 12x. We want to know the sign of f prime, so we're going to factor it. We can factor 4x out, and the second factor is x squared minus 3, which factors further as x minus root 3, x plus root 3. So to find the sign of f prime, we're again going to construct a sign of tables, finding the sign of each individual factor. We have three factors, 4x, x minus root 3, and x plus root 3, and f prime is a product of these three terms. So we may have a change of sign at negative root 3, at 0, or at root 3. And 4x is positive when x is positive, that is on the right of 0. It is 0 at x equals 0, and negative when x is negative. X minus root 3 is positive when x is greater than root 3, that is on the right of root 3, where it is 0, and it is negative otherwise. X plus root 3 is 0 at negative root 3, and it is greater than 0 if x is greater than negative root 3, so on the right of negative root 3, and negative otherwise. F prime is the product of these three terms, so on the interval negative infinity, negative root 3, we see that all three factors are negative, so the product is negative, because it's a product of an odd number of negative factors. On the interval negative root 3, 0, we have an even number of negative factors, so the product is positive. On the interval 0, root 3, we have one negative factor, so the product is negative. And on the interval root 3 positive infinity, all three factors are positive, so the product is positive as well. And the interpretation in terms of increase or decrease for f is that the function f is increasing on the interval negative root 3, 0 and on the interval root 3 infinity, and decreasing on the interval negative infinity to negative root 3 and on the interval 0, root 3. From this, we see that we have two local minima at negative root 3 and root 3, and one local maximum at 0. More specifically, f has a local minimum at negative root 3 and another one at root 3, and when we plug either one of these values in the function f, we get plus or minus root 3 to the power 4 gives us 9, minus 6 times root 3 squared, so minus 18, so we get negative 9 in both cases. On the other end, at 0, we have a local maximum, and to obtain this maximum value, we plug x equals 0 in the function, we get 0 minus 6 times 0, so 0. Moving on to the next function, we're considering the function x minus 2 sine x, but we only consider the restriction to the interval 0, 3 pi. Since we are looking for the intervals of increase and decrease, we know that it depends on the sign of f prime, so we start with differentiating the function. We obtain 1 minus 2 cosine x, because the derivative of sine x is cosine x. And we want to know when f prime is positive and when f prime is negative. If we solve the inequality f prime positive, we see that f prime is positive when cosine x is less than 1/2. So now we are considering the function only on the interval 0, 3 pi, and we're looking for the sign of f prime. And we see that the sign of f prime depends on whether cosine x is less than 1/2 or greater than 1/2. So here is where the cosine would be 1/2. Right? Remember that if you pick a point on the trig circle, the cosine of the corresponding angle is the projection on the x-axis. So for instance, cosine of pi over 3 is 1/2. So when x is 0, when the angle is 0, like for instance for this point, you see that the cosine is 1, and therefore greater than 1/2, so the derivative is going to be negative. And this is the case for any value of x up to pi over 3. You see that the projection on the x-axis for any one of these angles is between 1/2 and 1. In other words, the cosine of angles between 0 and pi over 3 is larger than 1/2, and therefore f prime is negative on that interval. Then you see that if the angle is anything between pi over 3 and 5 pi over 3, the projection on the x-axis is smaller than 1/2, and therefore the derivative is positive. For angles from 5 pi over 3 up to 7 pi over 3, in other words, doing a full revolution plus pi over 3, we are again on a section of the trig circle where the projection on the x-axis is greater than 1/2, and therefore the derivative is negative. From 7 pi over 3 to 3 pi, the projection on the x-axis, the cosine, is again less than 1/2, and f prime therefore is positive. The interpretation in terms of increase and decrease of the function is that the function is decreasing on the interval 0 pi over 3 and on the interval 5 pi over 3 to 7 pi over 3, and increasing on the interval pi over 3, 5 pi over 3, and also on the interval 7 pi over 3 to 3 pi. That gives us two local minima at pi over 3 and 7 pi over 3, and one local maximum at 5 pi over 3. To obtain this local minima, we plug in the value in the original function. So for instance, at pi over 3, we obtain pi over 3 minus 2 sine of pi over 3. Sine of pi over 3 is root 3 over 2, so we obtain pi over 3 minus root 3. At 5 pi over 3, we have a local maximum, and we obtain 5 pi over 3 minus sine of 5 pi over 3, which is negative 2 root 3. Negative root 3 over 2. So we obtain 5 pi over 3 plus root 3. And similarly, we have a local minimum at 7 pi over 3, which is 7 pi over 3 minus root 3. Now it's time for you to do some homework before you turn to the sample quiz and then the quiz.